We're on. Okay, good afternoon. Welcome to Mr. Mickleburgh's Maths Wells. The integral of equations or functions featuring e to the power of x. Now we saw before that the derivative of e to the x is e to the x. So it stands to reason that the integral of e to the x is e to the x plus c. Okay, plus c. Don't forget your plus c when we are talking about indefinite integrals as we are here. Let's have a look at some of these. Okay, now if we were to find the derivative of this, not the integral but the derivative, it would be surely 6 times e to the 6x minus 2, wouldn't it? I'll repeat that. Often when we are evaluating integrals featuring e to the x, we're in fact looking at the derivative first. And looking at the derivative here, we would certainly find the derivative of the index, put it out front and repeat this part of the expression. Okay, so that means if the derivative is 6e to the 6x minus 2, why don't we have a look at this? 1 over 6e to the 6x minus 2 plus c. That is going to be our integral. And we can check that by going back the other way. Finding the derivative of this expression. So here's the integral. If we find the derivative, we would expect to come back to this expression here, wouldn't we? So finding the derivative of this, the 6 here would knock out the 1/6 there. So that is our integral. Okay, looking at our second example, you're going to find that if you've got x and then followed by e to the x squared, what you do is you look at e to the x squared. Plus c. But an adjustment has to be made. Why does it have to be made? Because if you look at the derivative of this, right, the derivative of x squared is 2x. You're going to take the 2x out front and then it'll be e to the x squared. But here we've only got a single x, haven't we? Not 2x. So we'd have to halve this. And you'll find, lads, that by differentiating this expression here, you're going to end up with what's next to the integral sign. So that's that one there. Now continuing on to our third example, we can integrate really quite complex expressions. Here I've got 1 minus 2x and e to the x minus x squared. What happens if we just write this down? E to the x minus x squared. We're going to have a plus c, of course, because we are integrating. Okay, well if I do my differentiation here, I get 1 minus 2x, which is a lot like that. In fact, it is that. So that must mean that that is the integral of, the derivative of this will come back to the expression next to the integral sign, doesn't it? So that's my answer there. Can we stop the tape, please?